All right, so kind of piggybacking off of that Kahoot there, right? When we are looking at particular sets of data, oftentimes we are asked to find the median, we're asked to find the 25th percentile, the 75th percentile. Those are the relatively easy ones. But what about when we're asked for the 26th percentile or the 83rd percentile, right? Which the book definitely does. So let's talk about that. So when we're talking about measurements of position, right, we have a formula to figure out the location within the data set of a percentile. So this is a location within the set of data that you are, listing, right? So if we're talking about test scores, we would go ahead and we would order them. So we would order them from lowest to highest. So we'd go 80, 85, 88, 93, 100, or something like that, right? And so when we have a particular situation like this, it's very easy, right? We have 5 data points. So I can very easily be like, okay, this is going to be my median, 88. This is going to be my interquartile lower bound, right? My lower quartile. This is going to be my upper quartile here. But again, this is easy because we just have 5 points of data in this particular thing, right? So if we were to label this, we could say this is L1, this is L2, this is L3, this is L4, this is L5, right? Talking about the different positions of them. So when we're asked about the location of a percentile, we have this handy dandy format or formula. LP is equal to n plus 1, where n is the number of points in the data set, right? The number of values in the data set. And then we're going to multiply this by whatever the percentile is that we're asked to calculate. And then we're going to just divide that by 100. So the reason why quartiles have to do with, 25% or 75% has to do with the name, right? Quartile is having to do with a quarter of the full distribution, right? So that's why the lower quartile is the lower quarter of the distribution, the lower fourth of it, 25%, and the upper quartile is the upper 25%. 1 minus 25 is 75, obviously. Now, let's go through this formula, even though it seems silly, and figure out where the upper quartile is for just this really simple data set here. It's gonna get more complicated in a second, but let's just solidify, what we're doing intuitively here now using this formula, right? So if I asked you for the upper quartile, you would have to figure out the number of observations in the sample, right, which is 5. So we do 5 plus 1. And then when we multiply that by, and if I asked you for the 75th percentile, we would take 75 and we would divide it by 100. This would give us 6 times 3/4. 6 times 3/4 is going to just say 4, right? So this is our 4th position. 4th position. 1, 2, 3, 4. Similarly, right, if we wanted the 25th percentile here, we would do 5 plus 1 times 25 over 100, which is equal to 6 times 1/4. A fourth of 6 is equal to 2. So the position of the 25th percentile is the 2nd observation, which indeed we saw that it was intuitively just by having a very simple data set of just 5 observations. So questions on 25th, 50th, right, which is obviously 50th is the median percentile. I guess I should put it in here because it might not be terribly obvious, but yeah, the median is always 50 percentile. Or the upper quartile, the 75th percentile.
I guess just mathematically as a question, the n plus 1, is that another one of those things where it's increasing just the fudge factor of the equation just a little bit, or is there like a...
No, this is it. This is the reason why we're doing this is because, like if you think about it right here, like we have 5 sets of data, and so in order to get the numbers right, in order to get just 2, so when we have odd numbers of data, we have very easy time figuring out the median and the lower and upper quartile because of the fact that, we don't have to take an average of these 2, right? So let's say that let's say if we had another, if we just added to this data set, if we had one more person enter the class and they got extra credit, then now we have 6 observations here, right? And now, again, if we wanted to just very, intuitively figure out the median, we would take those 2 values in the middle and we would average them out. So we would end up with 90.5, right? 88 plus 93 spread of 5. So we take the difference, 2.5. We add it to the 88 to get 90.5. So that would be our median there. And so let's real quick do the L for the median. So L50, this one is equal to 5 plus 1 times 50 over 100, right? So this is going to be 6 times 1/2, which gives me 3, which sure enough, that's what it is, right? The third position is my median. Now, what if we have this situation that we see here, L50, but now we have 6 observations here. Now we're going to end up with 7 times 1/2, which gives us 3.5. So the 3.5th position tells me that I need to average the third position and the 4th position. So anytime we get a half there, that's just telling you that you need to take the average of those 2 values. So it's not necessarily the same reason as the sample to the population fudge factor. And that also, I did a little bit more research on that. And let's make sure I get it completely right. So there's a bias. So I kind of didn't completely talk last time when we talked about the n-1. So the reason why, so this is just kind of a little aside, the reason why we divide by n-1 in sample is to correct a bias that exists. And the bias is this. The sample mean, hold on. So I apologize. I just want to make sure I get this right. Okay. So the estimated value of the population mean, yeah, this is all too complicated. I'm trying to figure out a way to simplify it. The sample mean, here it is. The sample mean, which is x bar, right, as opposed to mu, which is the population mean, right? The sample mean is going to be drawn toward the center of the mass for the data.
Oh, because statistically you're more likely to pick things around the median.
When you take a sample, you're just more likely to get less of a spread than if you do the full population. And so your sample mean is going to consistently be biased towards whatever the center of the mass is for that data. So that's why we divide by n-1, is to correct that bias. Because if we were using the population mean, we wouldn't have this error. essentially? Good question.